Hi again. Well, I ended up cutting that video off right there at the shuffling part because I made a mistake in my second simulation, so you haven't seen that. And my editing skills aren't that great, so I just cut it off right there. Now I've shuffled my cards really well, and I'm going to deal out 15 and 15. But I just want to acknowledge that this is a fairly complicated setup for this simulation, so I don't want you to worry about the details, okay? But for some folks, it does really help, especially if you're a tactile learner. It does help to go through this with the physical cards to understand what the computer is doing. But I don't want you to worry about it too much, and then we're going to switch to the computer in just a minute, okay? So I'm on my second trial. The first one was with the blue cards. We got 7 improvers in the dolphin group, and so that meant there were only 6 improvers left to be in the control group, and we have our difference. So now I'm going to alternate with the red and black cards, the black being the improvers. I definitely would not ask you to set one of these up on your own, okay? Okay, great. So now we're going to count, same as before, we're going to count the improvers in the dolphin group, which are the black cards. We're only counting the improvers. We're not counting the non-improvers. 1, 2, 3, 4, 5, 6. Okay, so this time I got 6 improvers in the dolphin group, and because there's 13 total, that means there were 17. So this time 7 out of 15. So 6 out of 15 minus 7 out of 15. You can see the same value but opposite sign. Let's do it one more time. So I'm going to pause and shuffle really well. Okay, so I've shuffled really well, and now I'm going to deal out again 15 and 15 as if there's no difference in the two groups. Okay. Now again, we're going to count the improvers in the dolphin group. So those are the black cards. Okay. Set the rest aside. 1, 2, 3, 4, 5, 6, 7. Okay, this time we got 7. So does it make sense to you that if there really is no difference between the two groups, it would be around 50-50? So this time we're back to 7 over 15 minus 6 over 15. So let me calculate these. Okay, so 7 over 15 minus 6 over 15. And yes, we could also just do 1 over 15 because they have a common denominator, which is really nice. 0.06. And let's see, I'm going to think about what I have on my graph. 0.67. I don't think I need to go out any more digits than that because I can't do that accurately on the graph. 0.67 or 0.7 would also be fine. Now the other one should just be the negative of that, right? I'll show you. 6 over 15 minus 7 over 15 is the negative of that. And then back to the same one, 0.67. Okay, so let me put that on my graph. Let's see where this graph is going to go, or where the points are going to go on the graph. Okay, so 0 is no difference, right? And we have 0.1 and negative 0.1. So this is actually 0.067 is less than 0.1, right? It's actually 2/3 of the way over. Okay, so I'm going to put a dot right there, and then another dot, and then one on the negative side. Okay? Okay. So, and you might see, if this is an online class, you might see a link with a survey to put your results in so that we can get the full graph, okay? Not enough to do just 3, but what do you notice so far in the graph? So it's a little hard to tell so far. So we need to really do more samples, okay? So let's go to stat key test for a difference in proportions. And we're going to enter our observed proportions for the response variable improved in each group, okay? Go over to stat key. Okay, so stat key, so this time we're doing a hypothesis test, so that means we're going to be in the right-hand column. Test for difference in proportions. Okay, and again, there's some data sets you might be directed to inside here, but we're going to enter our own for edit data. And this is where we need to go back to our table to pick out the two oops, sorry, I have to go back to the notes for a second. Pick out our two proportions. So we're counting those improved. So 10 out of 15 and 13 out of 15. Okay, we will come back to this 13 later on, but at the moment it's 10 out of 15 and 3 out of 15. So 10 out of 15 and 3 out of 15. Okay, so that is our original sample, and then you can see that there are some different methods, randomization methods. So there are a couple different ones when you have more than one proportion. So what we were doing was the reallocation. So essentially is assuming that these are all one group and just redealing 15 and 15, right? So if there's no effect, then we could just be like, well, the improvers were going to improve, the non-improvers were not, and they're all in the same group essentially, and we just divide them in half, 15, 15. Okay, so I'm going to do one of those, and you can see it's a lot like our simulation because we're simulating the null. The trials I got were 6 and 7, okay, so that's exactly one of our trials. And then here we got a little different one. Here we got 8 and 5. So bigger differences are possible, right? They're just less likely. So you might indicate something about the shape of this graph, right? So there's a bigger one on the negative side. Okay, and then there's some bigger ones, but a lot in the middle. Okay, so I'm just going to go ahead and do the 2000. Did you guess that that's what was going to happen, that we're going to get a normal curve? It seems like we always do, right? So if there really is no difference, then we should get, right around 0 more often. It's still possible to get a larger difference, but it's less likely, right? And so that's what this graph shows us. Okay, so let me see where we're going next. Yes, okay, so I need to find my p-value. So we are doing a right tail test. Let me go back up here for a second. Remember, we're doing a right tail test because we want to see if the dolphin is significantly larger. Dolphin group was significantly more improved than the control group. So let me add right tail test, okay, and then we're going to put our observed statistic, which we haven't actually calculated yet, but StatKey will do that for us. We did it with our simulations. There we are. Okay, so I click on right tail for right tail test. The difference in the experiment, what happened is group 1 minus group 2, you can see is 0.467, okay, and that is the difference of 7, right, 10 over 15 minus 3 over 15. Okay, so we need to know how likely was that under the null. So I need to click on the lower right box and type in the observed statistic 0.467. And then we see, okay, that rarely happened in the simulation. It looks like maybe one or slightly more, 0.00098. Okay, so that's our p-value, right? That's the chance of getting the difference that was seen in the experiment or toward the tail, which is also evidence against the null. The chance of getting that or toward the tail was extremely small if the null is true, right? So that's when we end up rejecting the null and we say there is evidence of a significant difference. Okay, so let's go back to the notes and look at that. I'm actually just going to write down my simulated p-value before I do that. I got 0.00098. That is usually more digits than it goes out. Okay, great. So I wanted to write that down there, and let's write our conclusion, and then I'll highlight some stuff on the screenshots for you. Okay, so with a p-value of 0.00098, or you could do 001, the result is statistically significant. Okay, we reject the null hypothesis, and we have strong, that's a very small p-value, so we have strong evidence. Strong evidence that there were more improvers in the dolphin group. Dolphin group than the control group. Okay. There's, of course, a lot of different ways you could say that. We have strong evidence that the dolphin therapy showed a difference, right? Or so that's different. I'm just kind of stating it in terms of the improvers that we were talking about. And here is a simulation. You can see I got a slightly different value before, but that's totally okay. It's to be expected. So here is our randomization dot plot of the null hypothesis P1 equals P2. So notice how this time we didn't have to enter our null value because it's always with two proportions. It's always that they're equal to each other, okay? So that's kind of nice. When we have a single proportion, we have to put in our null value. But here it's always 0 or that they're equal to each other. Okay, and then we had our 10 out of 15, our 3 out of 15, right? And so this was our observed statistic, the p hat D minus p hat C, dolphin minus control, right? And then we put that same value down at the bottom because we need to see, well, how likely is that under the null? And it was not very likely. I got 0.005 in this one. Okay, same decision either way. Those are both very unlikely, right? Very unlikely under the null. So that gives us evidence for the claim or against the null. Okay, so that is our simulation. So we did a kind of brief introduction and simulation, and then I'll see you in the next video.